So we have made it halfway through the year, guys. We made it to our 6th chapter. And this chapter kind of takes a little bit of a detour more into probability and things of that nature. You can kind of see we're going to be discussing ratio and proportions. And just as a little reminder, whenever we talk about ratio, this is something that a lot of people kind of get a little forgetful about. Ratios are just a comparison. It's just a way we compare two things. So usually we represent these more as either fractions or as the actual ratio itself. Like you might see 10, the ratio 10 to 7, or this could be written as 10 over 7. So ratio could be written like this with a colon, or 10 over 7 as a fraction. Now, scale factor, this is going to be something we don't really talk about today. We've actually seen this in previous chapters, scale factor. We talked about that a little bit at the beginning of the last chapter. This is going to be more in the future. We're going to discuss if we live that long, if we don't die. Scale factor is going to be more in the future, but proportion. If you remember, that's what our topic was going to be, is ratio and proportion. And a proportion is whenever you have two fractions or two ratios, same thing, and you set them equal to each other. And we see this here. A is to B as C is to D. You form a connection here. You say, hey, A and B are related in the exact same way that C and D are related. And we can represent proportions with two different kinds of terms in these proportions. So first, we have extremes. This is your first and fourth term. So this is A and D. This is the very first term and the very last term. Well, then you also have means. These are kind of your middle terms. We know mean is like the average, sort of the middle-ish. So B and C would be your means. And again, you can represent these over here. We call it the first term and the fourth term. And then you have the second term and the third term. And what you can do with these is we see cross products. This is the same thing as cross multiplication. We're saying that you can take A and multiply that to D, and you can take B and multiply that to C. And that these are connected in that way. You can multiply these to where you end up getting A times D is really equal to B times C. And so some quick facts to know about ratios and proportions. We can, I love this word, you don't see it very much in math, you can always cross multiply to solve proportions. Always to solve proportions. And a geometric mean is just what we call the means when all numbers are positive. We're not really going to spend too much time on that. But that's just whenever the means, the numbers in the middle, are positive. There are 5 legal things we can do. So there's some illegal things. We're not going to talk about those. But there are 5 legal things you can do to a proportion that still make them true. So the proportion is still true even if you do these things. You can invert. So even if you have something like this, A over B, C over D, rewrite that here. You can flip A and B and C and D, and that statement is still true. You could switch the means. So B becomes C and C becomes B. You could switch the extremes. D becomes A becomes D. Because again, when you cross multiply, you're still multiplying the same things by themselves. This is kind of interesting. You could take B and it stays in the denominator, but you add it to the top, and you would still get the same answer, and it would still be the same as if you took D over here and added it to the top. These statements are still true, and it works with subtraction as well. A minus B over B will still be equal to C minus D over D. So I'm going to give you guys a chance. I want you guys to try numbers 1, 2, and 3 for me. See if you can write the appropriate proportion based off what you're given here. And we are using this piece right here. Go ahead, guys. Give me your best shot on these three. All right, so we see that first they took the top and set it over the top of the other one. So then we took the bottom, Z, and set it over top of the other bottom one, X. Then number two, all they did was they flipped the fraction on the second one. They inverted it, so we flipped D and C. And then finally, it looks like they took C and added the denominator. So we took W and added X, the denominator. Okay, now speaking of cross multiplying, that's all we got to worry about here whenever we're finding X. Anytime that you're finding something in a proportion, remember, you can always cross multiply to solve proportions. So just a quick reminder, when we cross multiply, we take the top, multiply this to the bottom here. If you call this butterfly method, I will hate you forever. So don't do it. Equals, we're taking 6 and multiplying it to 5x minus 4. So then we distribute on both these. You get 8x plus 40 equals 30x minus 4. And again, pro tip, I always try to keep the x positive because I know I'm going to have to divide at the end. So I'm going to subtract 8x over, which means I'm going to need to add 4 over to this side. If I'm bringing the x to the right, I need to move the regular numbers to the left. So 44 equals 22x. Divide by 22. And some of you guys have already had a chance to solve it. We know we get x. X equals 2. There. Now, fun fact on number 2. Exact same thing. It may look a little different, but remember, a ratio is really just a fraction. And so I'm going to let you guys pause and try number 2 for me. Okay, so we set it up. You guys cross multiplied. We got x equals 18. Now, on to applying this to a little bit more interesting problems in a variety of ways here. Same exact concepts on page 2. But this time, we want to double check and determine whether each pair of ratios is a proportion or not. So remember, these are fractions that need to be equal. So two ways to do this. I'll give you guys both ways here. Either option 1, reduce fractions. For those of you who are really good at reducing fractions, if these reduce down to be the same thing, you know you're good. Option 2, cross multiply. If you cross multiply and you get the same thing on both sides, you're good. So 2 options here. So for example, if I reduce down 6 over 15, I can divide those both by 3. That is 2 over 5. 9 over 22 doesn't reduce. These are not proportional, not proportions. Or you could have cross multiplied and you end up getting, I believe, 132 equals 135. And so literally either way, that way or this way, you get the same thing. So whichever method you guys want to try, you absolutely can. And speaking of trying, I'm going to let you guys try numbers 2 and numbers 3 for me, please. See what you guys can do with these 2 problems here. Okay. So cross multiply. I like the cross multiplying method myself. 72 equals 72. Yes. Cross multiply. 12x equals 12x. Yes. And so now let's get into some geometric examples. So we have a line segment, and we know that x has a length of 30, y has a length of 25, and z has a length of 50. And so if we're going to do the ratio of x over y, that would be 30 over 25, which you guys know reduces down to 6 over 5. So we want to obviously write these in simplest form is the key. How about this one? X plus y, that'd be 30 plus 25 compared to 50. So you get 55 compared to 50, which is really a fraction. And if you divide those both by 5, you get 11 over 10. So I'm going to let you guys try number 3 for me. See what you can do on number 3. All right, and on number 3, 50 minus 25 gives you 25 as compared to 30, which we know reduces down to divide them both by 5, 5 over 6, or 5 to 6, if you want to write it like that. All right, and so let's finish up video 1, guys, by talking about how we can use ratios to help us find the measures of sides or angles. Hey, and we're throwing it back to chapter 5 here, little chapter 5 throwback. We want to find the ratio. We want to find the sides. So again, or angles. That's our mission. And then on top of that, we also want to classify the triangle. And we're told that this triangle, the ratio for its sides, we've got, looks like 3x. And you're going to be, wait a minute, why are you putting x's with them? 4x and 6x. And that's because we don't know exact side lengths. We don't know exact lengths. Does that make sense? They give us a ratio and say, hey, this side compares to this side compares to this side, but we don't actually know how long they are, so we have to put a variable with those because we don't know the actual measurements. Now, we do know that they're going to add up. Perimeter is going to be 104, so they add up to 104 because that is all the sides added together. So you've got 3x plus 4x plus 6x all added up to be 104 feet. So what I want you guys to do, I want you to solve. Remember, solve for x. Use that to find the sides. And then label the triangle based off its sides. So let's see if you guys can finish this problem. Okay, so we got solved it out. X is 8. You plug that back in, we get 48, 16, and 12. So how would you guys label this triangle? Well, I would say if no sides are the same, we've got ourselves a scalene triangle. All right, and so this time, I'm going to let you guys try 5, but first, keep in mind we're trying to find angles. And so instead of being given a perimeter, what do all angles add to be? That's right, 180 degrees. So keep that in mind, guys, as you create your triangle here. We'll go 4x, 5x, and 6x. Because again, we're talking angles. And so I'm going to let you guys see if you can solve and classify that triangle. Let's go ahead. Okay, so I worked this out, add those up to set it equal to 180, solved it for x. I got x is 12. So then I plug 12 back in. I've got my 3 angles, and I notice none of these angles are bigger than 90. So we have an acute triangle, but also none of the angles are the same. So we also have just like last time, if none of the angles are the same, that means none of the sides are the same. We have an acute scalene triangle. And again, acute means no angles bigger than 90 degrees. All right. So that'll be the end of part 1, guys.